Okay. So for those of you who haven't downloaded the demo starter code yet, please do so. I updated it pretty recently, so if you downloaded it, like say earlier today or like in prior days, you might have to re-download it again. But yeah, let's just wait for people to download the starter code again and then put it in their appropriate directories. Okay. So while people are downloading, I'm going to quickly demonstrate what we're going to be building today. And you can see I was like actually testing it earlier. But right, let's say I'm trying to register onto this app or like this website, right? I'm trying to create an account on it. And I send in my credentials. Let's say my email is to be like my Cornell email. And then my password is, this is my password, right? So if I send this request to this register endpoint, what's returned to me, okay, the user already exists. Let's make a new one. Let's do Jessica. So, okay. So if I create a user, right, what's given back to me is a session token, a session expiration date, and an update token. So the session token, right, these string of numbers and letters don't mean anything to anyone. They don't mean anything to Jessica. They don't mean anything to the hackers that intercept this session token, right? The point of this is to be just like a random, combination of letters and numbers that you send in every time with your request. So one, it's much harder to guess, right? If someone is to like guess your session token. Two, it doesn't reveal any information about like the user's username and password and whatnot. So this is a secure way, right, of like sending in with all of your requests if you wanted to hit like a protected endpoint. And what I mean by protected endpoint is, let's say you're on like Instagram, right? And you want to edit your profile. Would you want anyone else editing your profile? Probably not, right? So the only person who should be able to hit this endpoint of editing your profile should be you. And the way you verify that it's you is by using the session token. This expiration, again, is configurable. So for example, right, we have different apps or like websites where you get logged out after a certain amount of time. And that's what the session expiration thing is for. And the update token serves a semi-similar purpose to session token. Basically, if your session token expires and you're like, this session token is no longer valid because, I don't know, it might have been compromised or someone may have gotten their hands on it, we want to refresh these, right? We want to get a new pair of session token and update tokens. And the way we do that is by using the update token to verify that, it is still this user that's trying to update these tokens. A lot of apps, so for example, on Google Drive, right, you might have noticed that they've optimized it in recent years such that you don't actually have to log in every month or so if you're using it consistently. And that's because this process of updating the session just kind of happens behind the scenes for you. So you can manually do it, right? If the session expires, the users have to log back in. That's like one way of configuring it. Or you can also set it so that if it's close to expiring, you can just update it for them. So that's two ways of setting up sessions. So does that make sense of why we have these two different tokens? Cool. So if that is all good, then I'm going to open the demo starter code. And let's just run through what is in each of these files. So let's open a new terminal and create a virtual environment. And while we wait for that to happen, right, so let's just explain the file hierarchy that we're starting with. So you might have noticed that like so far in this course, right, we've worked with two files, an app.py and a db.py, right, two Python files. Now we have a users DAO.py. This file is really not that scary. It is just a file containing helper functions. So if you remember the syntax from PA4 or demo 4, all this is doing is querying the user table and looking for the user with like a given email, right? All this is doing is querying the user table and looking for the user with the session token. Same thing here with the update token, and the rest of them we'll implement our own. So these are just helper functions, so we don't have to type this out every time we want to make one of these queries to the database. So does that make sense? Cool. In our db.py is one model, a user model, right? And it has a few functions to it. So let's go through what each of these do. So the user model has an ID, obviously. It also has an email, and it also has a password. We call it password digest, associated to each user. And this is just the email and password combination, except in apps, right? In apps in general, we never want to store our users' passwords as like raw text, right? If let's say you're logging into some sort of website or app, and you know that the owner of that app has access to your password, would you want that? Probably not, right? So the way we're going to be storing passwords is by encrypting them. So changing them into also another combination of just like random strings and numbers that will be not like identifiable if like the owner sees it, right? But it can be decrypted back to your password in order for you to be able to verify that this password is like still the correct email and password combination of the user. The session token is what I just covered, right? It's just like the random string that is used to verify that this user is indeed, in fact, this user. Expiration is when that session expires, and the update token is, again, another token, a random string, that is used to update the current session that we're working with. So we have an init function as well. And in the init function, using the keyword arguments that we covered in demo 4, we retrieve the email and set the user's email to be the email that's passed in. We can see that the password is a little complicated. So you can feel free to read the documentation on each of these like functions if you want to. But basically all it's doing is converting a raw password, say like, let's say my password is like, I love dogs, right? We convert that into like a random string of letters and numbers, which can then be decrypted back into I love dogs. However, the owner only sees that random string of like letters and numbers. So that's what this is doing. It's just encrypting it. Renew session is a function we wrote down here, right? So we're calling a function called renew session, and basically what it does is, it creates a new session. So I guess like the better way of saying it is that it renews a session, because if a session already exists, it'll just update the existing one. But I guess in the case of like your first time calling this function, it'll just create that session. So what creating that session means is creating a new session token, setting some sort of expiration to it, and creating the update token. And you can see that the session token calls this function called URL safe base64. That basically just generates one of these. And this is just, so it's, not too much to read into. Just look at the documentation if you're really curious. And then I guess another cool thing is like, you can see the session expiration thing right here. It says datetime.datetime.now. So that's the current time that we say like create this user or call this function. Plus datetime.time delta, which just means the difference in time, days equals 1. So this means that if I call this renew session, then my session will expire in exactly 1 day. But I can configure this to whatever I want it to be, right? So if we want our users to be logging in every week, we can do week equals 1. Or if we want it to be every, hour for whatever reason, we can do hours equals 1. So that's what this renew session function does. Verify password, again, another function that uses some of our libraries. So again, feel free to read up on the documentation, but this basically just checks if the password that's stored in our database, the encrypted version, matches the password that's passed into us. Yeah. And verify session token checks if the session token passed in is equal to the session token that's stored in our database. So if someone tries to like hack your account and passes in a malformed session token or like a wrong session token, right? This will return false. In case that it's you, it will return true. And this part is checking if the current time is like before the expiration, right? So if it's past the expiration, we're supposed to not be using that session token anymore. So this will return false in that scenario. Finally, update token just checks if the update token matches the update token stored in the database. Cool. Does that make sense? Okay. And then our app.py has a few endpoints. And we'll be covering how to implement each of these. So we have our generalized response formats that we've seen since PA4 or PA3, I think. Extract tokens. So again, like Jessica covered in lecture, right? Each HTTP request has multiple parts to it. So if you look in Postman, right, you have your request method, you have the request URL, you have the request body, and you also have this thing called request header, which is this tab right here. And this is where we're going to be passing in our session token instead of in the body. This is just standard practices. Usually the body will contain more like, I guess, concrete data, where as opposed to headers, which contains much more like over under the hood kind of thing. So like the content type is like this. It's like saying that my request will be a JSON, right? And like the type of host we have, and all sorts of things that you don't really have to worry about. But the authentication, like the session token, will be sent in through the header. So what this function back here does, extract token, just takes the request and tries to extract the session token out of it. So we'll be implementing that in a sec later too. And then the endpoints we want to be covering is register for registering an account, right? Login for logging in. Oh, oops. Update session, right? So if like we have an automated system for this, we'll just be hitting this endpoint like every so randomly. Otherwise, we'll like make the users manually hit this endpoint when they want to update their session. We have secret message. So don't get fooled by this. Basically, what this is kind of trying to mock or model here is if you have any sort of protected endpoint in your final project or any project you worked on in the future, the logic that we'll use in secret message will follow the logic you'll be using to like protect your endpoints. So what this means is like, again, like going back to the edit profile example, right? You should be the only person who's able to edit your profile. So the logic of like extracting the header and like verifying the session token will go in here, just like it would if you had an endpoint for editing your profile. And then finally, just logging out. Okay. What did it change? Oh. Cool. Does that make sense to everyone? The endpoints we'll be covering. Yeah. Awesome. In that case, we can start with, right? The first step when you want to start using an app is probably to register an account on it, right? So let's do that. Let's define this endpoint. So the first thing we're going to do is, instead of actually implementing a lot of the logic here, we'll go into our user's DAO file, because that's where all of our helper functions are, and create a function called create user. So what this create user function is supposed to do is it creates a user object in the database and returns the user object if the creation was successful. Otherwise, like if the user already exists, it should return false, or like some sort of error, right? So that's why when I like try to make, like if I try to make Jessica's account again, start the app back here, right? It'll tell me that the user already exists. So, right, that logic will be handled in this function. Okay. Let's start coding. So in create user, the first thing we'll do is do optional user is equal to get user by email, and we'll pass in some sort of email. So this email is passing through the parameter. This get user by email is a function that we defined up here, right? It just checks if there's like a user that matches the email that we passed in, right? So we now have a variable called optional user if, and like tries to retrieve the user object with that email. And if that user doesn't exist, right? If the user already exists, if optional user is not none, so if this user already exists in the database, then that means that an account associated with this email already exists. And in that case, we want to return some sort of failure response. And the way we're going to structure the failure response is just going to be false and optional user. So in Python, you can do this cool thing. I don't know if this is covered in 11.10, but you can have two output variables or two output values. So in our case here, the first value is going to be if the if the creation of the user is successful or not. And then the second one is going to be the user associated to your request. So if the user already exists, it'll just return you that user that exists. And otherwise, right? Otherwise, if the user doesn't exist, then we'll create a new one, right? So we'll do that by doing user equals user, email equals email, password equals password. So this uses the quarks logic from PA4, and it just passes in the email and password that's passed into us through the parameter. And now that we've done that, the usual db.session.add user and db.session.commit. So we'll add this user to the database and commit that change right in the database. And since right we were successfully able to create this new user, well, this time we'll return true and the new user object that was created. And you might be getting the squiggly line under the DB just like I am. So the way you can change that or like help that is by going to the top of the file and from DB importing DB. So make sure you make that change. Go back to the code. So we created a new user. If that user already exists, we'll return false with the user that already exists. Otherwise, we'll create a new user and return true along with that user that was just created. All right, so I'm just going to leave this code up here in case people still need to copy, like so. But now let's actually call this function in our app.py, right? Okay, so register account. Last request. Okay, so at the top of our app.py file, we will have to import the user's DAO file that we created. This way, it'll give us access to use the functions that we actually created in a user's DAO's file. So do that. And then down in our register account endpoint, we can start actually typing up the logic for this. So the first thing we do is get the request body, right? Or JSON.loads request.data. And then we'll extract the email and the password. And we'll check if those fields were actually provided to us. So if email is none or password is none, then we'll return a failure response saying invalid email or password, or like missing email or password. Is it too small? I think I heard something. Is it good? Okay, cool. Yeah, so if the email is not provided or the password isn't provided, we'll give an error saying that the password or email or password isn't defined. Again, as usual, we'll pass in the error code of 400 because that's the user's, the front end's fault for not passing those two values in. And then we'll extract the two output variables from the user DAO create user function. So this function we just created, right, has two output variables or two output values. So we'll store both of those in two separate variables, success and user equals users DAO dot create user email password. So we'll actually pass in the email and password provided to us in the function we just created and extract both of the return values into the two variables. So success is going to contain false if it wasn't successful and true if it was successful, right? So that means that if not success, then we'll return failure response, user already exists. Also a 400 error. Otherwise, that if we pass this if statement, we know that the success, it was successful, right? So then we can just return success response with the dictionary containing the session token, which is user.session token. Refresh session expiration, also user.session expiration, and update token, user.update token. Okay. So we're running slightly on time, so I'm just gonna hit this endpoint and see what it does. So we've installed all of our requirements, and we're in a virtual environment. We're ready to actually run this Python file, right? So let's run that file, python3 app.py. And our server is ready to take accept requests. So again, the two things we have to pass in is the email and password, right? Again, just to quickly recap, the reason why we don't want to be passing in the email and password every time is because if someone intercepts the network, right? If some malicious person intercepts the network, then they can just get their hands on your username and password. But obviously, you will have to pass it in once to like register an account and to log in and whatnot. So just handle these just basically try not to send your email and password as much as you can. In case it gets intercepted. So this is the same endpoint. I can just hit the same endpoint right here. Instead of my Cornell account, or actually, let's just go back to my Cornell account and then change the password to like, I love Otani or something. And then we'll hit this endpoint and, oh, datetime is not JSON serializable. Oh, and I have to change this to a datetime. Yeah, I have to change this to a string because right now it's a datetime object. A Python object can't be returned as a JSON response, so you will have to convert this into a string. But once that works, okay, user already exists because parts of the logic ran, but not all of it did. So let me just delete this file. Okay, now if we hit this endpoint, right? So this is the same output that we saw at the beginning of the demo. The session token is given back to us with the expiration of like a day later, right? So like right now it's November 7th, 8/17. This is saying November 8th at 8/17, and then the update token, which we can use to update our session. Okay, so in the database we have one user with the email of that and the password of that. So that's what we'll be working with starting next lecture. Anyone have any questions or want me to show any parts of the code before we move on to Kahoot? Yeah.
So when you create a new user, like it automatically creates a session token, like using whatever.
Like library, right?
Yeah, library. And then, but you can still. Is that? May I just see that? Is that like a column, or does it create that anymore? Create user.
Yeah. So the db.py, like the database file. The only model in here is the user model, and you have like 3 fields for the session, associated to the session token, the expiration, and the update token. All of these are strings, or except I guess the session expiration, because you have to define when it expires. And then when you create the user object for the first time, you call this renew session function, which defines all 3 of those fields. Right. So like when you re-log in, you also call this function. You just call this function whenever you want to call it, and it'll update the sessions for you. Also, I guess one thing to note is you saw in lecture that and sorry, I'm going to go slightly over time, but you saw in lecture that, right, so users and tokens are traditionally stored in separate tables. The reason why we aren't doing this in this demo is 1, because it makes it overly verbose, but 2, because when you want to store multiple tokens per user is usually when you have multiple devices that are associated to a user that we want to be logged in on. So if you have an iPhone that's connected to an app and a computer connected to an app, we want to have 2 separate access tokens for both of those devices. But for now, just for the sake of simplicity, we're just going to be storing the session information along with the user. Does that make sense? Good. See some thumbs up. Cool. So we can move on to the Kahoot. Don't worry. Okay, we'll get started. So welcome back to Intro to Backend. Today we'll be finishing up authentication demo. Just a few quick announcements before we get started with demo today. The first thing, the drop deadline is today. I have a feeling that it doesn't affect anyone here, but in the chance that you are struggling or you don't feel like you can do it, you can either come up to us and try to come up with a solution, or just drop the class by the end of today. Second thing, Hack Challenge starts next week. It commences next week. And the mixer to meet other people from other classes, in our other app dev classes, is this upcoming Friday. I did make an ed post on this, so if you're curious about that, make sure you go check that out. Yes, any questions? Cool. All right, I guess we can just jump straight into this. So let's quickly cover what we discussed last time, right? So if I pull up Postman and run this again. So this user already exists, but if I'll change this to like Jessica's ID, right? If we hit this, we implemented this register endpoint last time, and the three outputs that it gives us is a session token, the session expiration, and the update token. And the session, right, is like kind of a session that you're currently in when you're logged into a certain app or website. If it expires, you can no longer use the service. So say you're on like Gmail, right? If you're logged in on Gmail and you don't use it for long enough, you'll get automatically kicked out, right? So that's what the session is. The token is to uniquely identify you, that like you are the correct person that is making this request. And the update token is used to refresh this token, right? To update the session token and kind of like retrieve a new value, just in case the session token gets compromised. Okay, so that's what we covered last time. Hopefully we're up to speed. Yeah, no questions about last time? Okay. In that case, we can get started with the next endpoints. I'm just going to delete all of these. Okay. So the next thing we want to implement is actually the secret message endpoint. And like I explained last time, what the secret message endpoint does is kind of, it's supposed to mock the logic that you would be using for a protected endpoint. And again, a quick refresher on what a protected endpoint is, right? Going back to the Instagram example, if you wanted to say edit your profile, right? You have an endpoint for editing a user's profile. You as a user should be the only one who's able to edit your own profile, right? You don't want anyone else being able to edit your profile. And so what that means is that we have to have some sort of way to uniquely identify that you are the one making the request. Now, obviously, we could use the user ID like we have been so far, but like say someone else finds out what your user ID is, right? Then you don't want them to be able to edit your Instagram profile. So the way we work around that is instead of using IDs, we use the session token, which is a random string of letters and numbers. And the server will take this in and be like, okay, well, this is you. And so therefore, I will give you the access, or I will give you the permissions to edit your user profile. So the secret endpoint, or the secret, this endpoint right here is supposed to mock that logic. It's supposed to take a session token and be like, this is the correct user. I can allow this person to do whatever operation. So the output's going to just say like you have successfully implemented secrets. But in your hack challenge or any future projects you work on, this is the logic you'll be using for any protected endpoints. So the first thing we want to do in your secret endpoint is to extract the session token from the request header. So this session token right here, instead of sending it along with all your other information in your request body, something like this, right? Instead of doing something like this, session token and other sorts of metadata goes in the request header. Oops, what did I just do? Goes in the request header. So that is this tab right here that says headers, right? And we have all these metadata that we don't really have to worry about for now. But if we want to make a request using our session token, we're going to have to add a new key value pair. Okay, so let's make a new endpoint. New request. Call it secret local host 8000 secret. right? And what we're going to pass in is just the session token. So right now we have a session token associated to Jessica, right? Who we made a who we registered onto our app. So we'll be using her session token to try to make a request to the secret endpoint. So the way we're going to add the session token to our request is under key, we type in authorization, and it's going to autofill for you. And in the value, we pass in bearer and then the session token. So this bearer is just kind of standard practices of like telling the backend what kind of HTTP scheme we're using. So if you remember from last time, we covered HTTP basic, HTTP session, and that's HTTP token, right? So for HTTP basic, instead of bearer, this would be like basic. But for now, we're using HTTP token, which the standard is to type in bearer. So that's what the request header is going to look like. And we're going to have to extract this information, right? And the way we've been extracting the request body is by doing JSON.loads request.body, but that's not the way we're going to be extracting the session header, or sorry, the request header. So we'll implement a function up here called extract token. And you can see here it says helper function that extracts the token from the header of the request. So we'll be implementing this now. So the way we extract the header from our request is by typing in auth header, which is a variable, and we're going to store request. I'm sorry, let me turn my autopilot off. Request.headers.get authorization. So just like we did JSON.loads request.body, this time we're doing request.headers, and we're specifically getting the authorization key value pair from the request header. Then if auth header is none, we'll be returning two values, just like we did with one of our functions from last time. Return false and JSON.dumps error missing authorization header. And this first return value is supposed to indicate if this function successfully run or not. And the second value is like, the value of like the operation. So if the response, or if this function is successful, we'll be returning true and some sort of value. So let's implement that. So again, I'm going to write a comment here. You don't have to type this down, but the header looks like authorization, and then bearer and some sort of token. Right, this is what the header looks like, just like we have up here: authorization, bearer, and then some value. Right. Okay. So per Python syntax, the way we're going to get rid of this bearer value is by doing bearer token is equal to auth header, right, which is the value here, dot replace bearer space with an empty string, and then dot strip. So what this is doing is replacing this value right here that says bearer with an empty string, which basically gets rid of this bearer, this part of the string, and just leaves you with a token. Okay. And then, right, let's say some person tries to like mess with our app and just passes in the value bearer, right? Like the value bearer. We're gonna have to prevent that. So we can check if bearer token is none or not bearer token, not bearer token. Then we'll also return false JSON.dumps. Oh, also instead of JSON.dumps, I should be using failure response. Yeah, should be using failure response. Sorry about that. Yeah, so if the auth header is none, then we don't have the authorization header, right? If we do have an authorization header, but then the value we're passed in is like invalid, then we'll do failure response as well. But this time it'll be, oh, and I should just be passing in the message. Invalid authorization header. Okay, that looks much cleaner. Then, right, if these two cases pass, then that means that our auth header existed and it's some sort of valid token, right? So we can just return true, the fact that this function runs successfully, and the bearer token itself. Okay, so I'm going to leave this on the side of my screen, like that, and then start working on the secret endpoint. So yeah, does this logic make sense to everyone? Right? We're checking if it exists, and then we're checking if it's valid, and then if all of those cases pass, then we just return the token itself. Okay, so now we have a function that checks if a token exists, right, and like returns a token if it does. So in our secret endpoint, we're going to be calling that function. So we'll do success and session token equals extract token and pass in the request. So this is similar to what we did last time, right? In our register account endpoint, we have success user equals create user, right? If this is successful, then success should contain true, and user should contain the, like the operation output itself. And likewise in here, right? If the extracting of the token was successful, then success would contain true, and then the session token variable would contain the actual session token. Okay. So if not success, right? Then if it wasn't successful, what do? We can just return failure response session token invalid. Oh, actually, no. This, yeah, 400. Okay. Then, right, if this function did run successfully, then we know that this token is like an actual token that is valid. But we don't know if a user with that token exists yet. So we have to retrieve that information. In our users DAO.py, which is a helper file, right, with a bunch of helper functions that we covered last time, one of our functions is called get user by session token. So let's call that. So if it is successful, right, then we can do user equals users DAO dot get user by session token and pass in the actual session token that was given back to us from this function. So now we retrieve a user by their session token, and we can check the validity of this user, right? So if you remember from PA4, this function right here, this like filter and then like dot first, the function will return none if a user with that session token doesn't exist. So we can check if that user is none first. User is none. Then we'll return JSON, no, failure response. Invalid session token. Here we can rename it to did not extract session token or something. Okay. And then otherwise, then the user like actually exists, right? So we can do a return JSON.no success response with the message that reads, you have successfully implemented sessions. So I'm going to leave a comment right here, but basically, right, this logic is what you would use for a protected endpoint. So if someone were to like want to, like request something that like for their account or edit their profile or something that, they should be the only one that's able to do that operation, then you would kind of follow this similar logic. And in here, you would like you know, logic of the endpoint, like editing their profile or something. So this would be the part where, like, you have like confirmed that this user exists. And then in here we would like actually handle like editing the profile or whatever operation that you would want to implement. Okay, so now let's actually hit the secret endpoint, right? So this bearer value, the session token that we got from registering Jessica onto this app is valid, right? So let's try passing in something that's not valid, like hello or something, right? If I try to hit this endpoint, invalid session token, right? This is not a valid session token. If I try to pass in nothing, could not extract session token because this is not, correctly structured. If I pass in nothing, also could not extract session token. However, if I pass in Jessica's actual session token, it'll give me a message saying that you have successfully implemented sessions. Right. And we have to do one more check here that I forgot about. Instead of just if user is none, because a user with that session token could exist, but the session could have expired, right? We have a helper function within our db.py file that checks if the session token is valid, right? Valid for verify session token. We'll check if the session token is valid and also check if the session has not expired yet. So instead of just user is none, we'll also call user.verify session token and then actually pass in the session token. And this way, if the session is expired, then we won't be able to use that session token. Okay, is everyone good so far? Cool. If you see a few nods, we can move on. So the next thing we can do is implementing verify credentials. So given an email and password combination, we wanted to check if this email password combination actually exists in our database. Obviously, right, if you couldn't tell already, the reason why we would implement this function is for logging in, right? When we log in, we want to check if that user and or the email and password combination passed into us is a valid one of a valid user. So we will go to our users DAO again, our helper file. And I'll implement this. So the first check we want to do is if the email exists in the data, if a user with that email first exists in that database. So just like we did down here with the optional user, we'll get a user by the email passed in, right? And if that user doesn't exist, then we'll return false and none. So a lot of these functions will be returning, like the first value is like the indicator if it was successful or not. Then the second value is actually like the output of the operation. Yeah. Okay, so right now we've retrieved the user by their email and checked if that user first exists. If we got to this point, if we got past this if statement, then that means that a user with this email definitely has to exist, right? So the next thing to check is if the password is correct. And if you look in the db.py file, we have a helper function called verify password using some of the library functions that we talked about last time that checks if the password that's passed in is the same as the password stored in the database for that user. So we can just do return user dot or optional user dot verify password. Right, so this will return either true or false. If it was true, then that means that the operation was successful, meaning the email and password combination actually exists in our database. If it was false, then that means that the email was correct, right? Like some user with that email existed, but the password was wrong. And then we'll also return the user along with it. Okay. I don't see too many people copying, so I think I'm free to move on. Okay, so we have implemented a function called verify credentials that returns true or false. False if that user and password combination doesn't exist. True if it does, and the user along associated to it if the user and password combination does exist. So now we'll implement logging in, right? We have users registered on an app, right? And so now we want to figure out how we can actually let them log in and log out of our app. Let's go to our app.py. And just like we have been this whole semester, we'll do body equals json.loads request.data to get the request body. We'll get the email, body.get email. We'll also get the password. And we'll check if email is none or password is none. Then we'll return a failure response, invalid email or password, or no, missing email or password. Let me shrink this a little. Right? So we extract the email and the password from the request body, and if either of them are none, then we'll return a failure response saying one of them is missing, one or the other is missing. Otherwise, that means that the email and password were passed, like some email and some password were passed in. So we can check if that email and password combination is valid by using the method that we just implemented, or the function we just implemented. So we'll do success. User equals users dot verify credentials, email, password. All right, that's the function we just implemented on the right here. Cool. Okay, so if this operation was not successful, so if not success, then that means that the user and password combination were incorrect, right? So we'll again return a failure response saying incorrect email or password. And I believe the unauthorized status code is 401. Yeah. So 401 would be the status code for like an incorrect combination of email and password. So we'll return that. And if it was successful, then we want to allow the user to actually log into our app, right? So then what we do is we'll return a successful response containing the session token, user.session token, the session expiration, the string version of user.session.expiration, and then the update token. So yeah, once again, to quickly recap what we just did, right? We extract the email and password from the request body, and then check if those credentials exist in a database. If they don't, then the email or password is incorrect. If they do, then we just return the successful response, returning the session token, expiration, and update token. So let's test this endpoint. Let's go to Postman again, and we'll make a new request. I'll log in. I'm looking at post request, localhost 8000, login. And then right? So we registered 2 users last time, or actually 1 user last time and 1 this time. One was my Cornell account with the password of I love Otani. And this time it was Jessica's with also I love Otani. Yeah, that's
I don't know what that is.
okay. So if you recall, last time I set the expiration of the session token to be exactly 1 day, right? That's this part of the code. So the session expires after 1 day. If you don't log into your app or log into my app for a day, you get kicked out and you have to log in again. That's kind of frequent, but you can change that to however many days you want it to be. So let's try logging in, right? User or email and password. So since the expiration is 1 day and I made my account 2 days ago, that means that my session is already expired. I'm already logged out. So if I try to type in my Cornell account with I love Otani, okay, it still will give me the session token, expiration date, and update token associated to my user. But if I try to use the session token, it's already expired. So I'm not going to be able to. But you can see that the logic is working, right? So if I type in my email and I type in my correct password, the details about my user is returned to me. If I misspell my password, right, incorrect email or password, and we did that check earlier. If I misspell my username, right, same thing. If I don't pass one of these fields in, it's going to tell me that one of my fields is missing, right? So I can log in and Jessica can log in. Cool. So does this logic make sense? Does anyone need me to explain this part of the logic? Yeah.
How come you're returning error response if things are incorrect instead of just like the login was unsuccessful?
Yeah, so the failure response is there so that our backend doesn't crash. If let's say like, right, the email and password combinations, like if email or password isn't passed into us, and we still want our app to be running, right? If we try to check the email and password combination when if one of their fields isn't like defined, then our app could crash, right? We don't have like some sort of error handling a lot of the time. So this failure response is just some sort of like abstract failure response. It's supposed to handle all kinds of errors, including user errors and like our server's errors, I guess. So if like the username and password aren't passed in, that's an error on its own. But if like the username and password combination don't exist, that's also another error response, and the front end can just handle that, like take that response and like display it on the front end being like, okay, you pass in one of these fields in, or like your email and password combination don't exist. So yeah, this failure response is supposed to handle like most abstract failures that you could have on your backend so that it doesn't crash. Sorry if that explanation was a little verbose. Any other questions? Cool. So, okay. So we have login successfully implemented, right? But like I mentioned earlier, my session token is expired. My session is expired. So if I try to hit the secret endpoint using my session ID or the session token. Oh, what? Okay. Eleven eight. Oh, this should be an or. Oops. Yeah, so if the user does not exist or the session token is invalid, then we should return this failure response. So that should be an or in the secret message endpoint. But yeah, again, my session token is expired. So if I try to verify session token. Oh, now it should be Session expiration is after, yeah. Okay, well, I can fix this pre-recording. I'm not sure why this is working, but ideally, right, if your session is expired, you shouldn't be able to hit any kind of endpoint with your session token. So that's the logic I was trying to demonstrate here. But let's just say it didn't work, right? Even though it's let's just say it didn't work. So how do we make it so that we can like actually refresh our sessions, so that our expiration is no longer in the past? Because if I log in, you can see my expiration was November 8th, which was yesterday. So that endpoint is this one right here, update session. And for updating session, right, we can implement our last function in our user's DAO file. I'm going to close the split screen. In our user's DAO file, we have one last function called renew session, which takes the update token of a user and refreshes that user's session. So we'll do user, right? Just like we've tried to retrieve, or we've retrieved the user by their email. This time we'll do get user by update token. So we'll get a user by their update token. And if that user is none, so we're just passed in like some random session or update token that doesn't exist, then then we can return false optional user, just like we have been. And this would just be none, so we can just do it false and none, because no user exists with that update token. And if that user does exist, right, then we can do optional user dot renew session. And this is a function that we have defined in db.py. I'm sorry I have to like keep switching back and forth between files that we or functions that we've already defined. But one of the functions that we have in db.py is renew session, right? It like creates a new session token for us, sets a new expiration date to be a day from now, and also sets an creates a new update token. So there's a function that exists in our user model. So we'll be calling that if the user actually exists. We'll commit that change. So db.session.commit. And then we'll return true, and then the optional user. So again, we get the user by their update token, check if they exist. If they don't exist, then we'll just pass in an invalid update token. So we'll just return false and none. Otherwise, we'll renew the session, commit that change, and then return that it was successful and the user associated to it. Okay. Okay, going back to our app.py, right? We have update session, which is our second last endpoint to implement. In our update session, we'll do success update token. So we'll extract the token passed into us through the request header. And we'll do success once again. And then the user. And we'll do users DAO.renew session and then the update token. So this will give me a user if that user with if a user with that extract token or sorry, update token exists. Otherwise, it'll just return me like none, right? So if not success user, then we'll return a failure response saying invalid update token. Otherwise, the user session has actually been renewed. That's just handled in the user's DAO file for us. So we can just return success response with session token being the new session token of our user. So user.session token. Session expiration is our new expiration date. And the update token is also the new generated update token. Oh, and then I also have to do a check here. So we'll check if the first success is true. And then if it wasn't, then the update token wasn't, extracted correctly. Our update token was malformed. Okay, so let's test this on Postman. Our endpoint is called session and it's a post request. So we'll duplicate this, call this up session, and we'll call the endpoint update session, right? So once again, to reiterate, right, if I log in, you can see that my session is expired. My session expired a day ago. So we want to update this. And to update it, we want to use the update token, right? So we pass that into the headers as well. Authorization is a key once again. Oops. And the value is also bearer and then some sort of value. You might be wondering, can I pass in both the update token and the session token in your request? The answer is like yes, but also you shouldn't. So only one, like you can't have duplicate keys, just like you can't have duplicate keys in a Python dictionary or a Java hash map. You cannot have that. But also you wouldn't want to pass in both the session token and the update token at the same time, because they serve different purposes. And also you want to be sending as little information as you can per request so that in case your request gets intercepted by some sort of like malicious user, right? Like less of your information gets compromised. So yeah, for updating a session, all you're passing in is the update token and not the session token. So if I try to pass in my session token, for example, and I try to refresh my session using the session token, right? Invalid update token. So that gives me an error here. If I try to pass in nothing, right? Could not extract update token. Same thing if I pass in nothing at all. But if I correctly pass in my update token, my account will finally be valid to be used again after 2 days of registering on this app. So let's do that. And you can see now I have a new session token, a new update token, and a new session expiration date of tomorrow. So I can like switch between these two tabs. You can see that my session token and update token are indeed different. And if I try to log in again, I'll be given my new session token and new update token and expiration dates. So if I hit this endpoint, right, my fields are now updated. So that's how we update a session. Cool. Finally, let's implement logging out. So what do you want to do if you log out a user, right? We have 3 things to take care of: the update token, the session token, the session expiration date, and the update token. Okay, so when we want to log out a user, we'll also have to extract a token. We'll have to extract a session token specifically to know that the user that's trying to log out should be the only one who's able to hit this endpoint, right? So we'll extract a token. And if it was not successful, if not success, then return I could not extract session token, same as up here. And then if the user is valid, users DAO.get, or sorry, if the session token is valid, then we'll try to retrieve a user by that session token. And if user is none or, oh, okay, I think I see my mistake with the secret endpoint. I'll fix that in a sec. But if the user is none or, right, not user.verify session token. So verify session token returns true if your session token is correct. It returns false if it is not. So we'll do return failure response, invalid session token. So again, we try to extract a token. We try to get a user by the session token. And if both of those things pass, right, then we have a valid user in our hands. So we'll do session user dot session token equals an empty string, user dot session expiration equals datetime dot now, and user dot update token equals an empty string as well. And we'll return success response with the message, you have successfully logged out. So the reason why we want to be setting the session token and the update token to be empty strings and the session expiration time to be now is because, you know, before we had a valid user session in our hands. However, this user wanted to log out, right? So that means that the session token should no longer exist, and the update token should also no longer exist until they log back in. And the expiration should be now because, you know, their session ended. They like force ended their session. So that's what this logic is doing. And you can see the orange squiggly under date time. I can fix that by just typing import date time up here. That's topmost style. Okay, so let's try hitting this endpoint. Logging out. So let's create a new request. Call it log out. Localhost 5,000, 8,000 log out. And the only thing we'll be passing in is a user session token. So I'm logging in here, right? You can see that I have a session token, an expiration day of tomorrow, and an update token. Let's say I want to log out. So I'll pass in, it'll be a post request because I'm passing in a value. And in the header, I'll pass in my session token. And if I hit enter, right, I get the message that I've successfully logged out. And if I try to log in again, it'll technically let me, but you can see that my oh, I forgot to commit this change. So db.session.commit. Right, so if I log out, right, and try to log back in, now I have no session token, no update token, and an expiration date of now. I have no information here to be compromised because none of this data is stored anymore. Okay, the quick fix in secret, and you know, if you're watching demo or like copying this down live, you should fix right now because you're probably going to be using this logic in your hack challenge. Is if user is none, right? So if the user doesn't exist, or not verify session token. So the session token was like invalid, then we should return the error. So don't forget this not. And if you notice, right, if I highlight this, the logic for secret and the logic for logging out is identical because logging out is a protected endpoint. So this is the logic you would want to use for any kind of protected endpoint in your hack challenge app. Okay. I know that was a lot, but that sums up demo 7, authentication. Do we have any questions? Also, just briefly, for hack challenge, we'll cover this later, but one of your requirements for your hack challenge project is to implement either authentication, so some sort of login system on your app, or to implement images, so saving of images in your backend, which we'll be covering next week. One or the other is required on your hack challenge. So there's no PA7 and there's no PA8, but you will have to use one of the two demos logic. So just keep that in mind. Yeah. You could use both, obviously. We're not gonna like, so again, we'll cover this later as well, but hack challenge has like prizes for winners, like who like do exceptional, right? And one of those prizes is for best backend. And so like, obviously, if you implement both, you have a higher chance of that. Although it's not going to give you a better score grade, because the grade is just dependent on if you implement one of them or not. Cool. Any other questions? Yeah.
Do you have any criteria for
That
that?
well, we like all like collectively come into like a room and like look at everyone's like code base, their backend like code base, and like see if like people do cool stuff. This will be covered more at the kickoff, so don't worry about hack challenge for now. Yeah, good questions. Anyone else? Yeah. Can we make it a hack challenge project to fix Ithaca Transit? That would be great. One of our apps is down right now, so if you could fix that, I will personally vouch for best backend for you, sure.
Why don't you join the team?
And you can take my place on AppDev. Anything else? Cool. Let's do like a Kahoot for today.